Hello, everyone. Welcome to the ShinyGatherings session. My name is Mateusz. I am our Shiny developer at Epsilon, and today with me, I have Valentin, who is a senior data scientist at Roche and product owner and overseer of the project we'll be discussing today. We also have Jana and Gerardo, data scientists and R developers at Roche and major contributors to the project. And today, we would like to introduce all of you to automated non-compartmental analysis. So, in terms of the agenda for today, we'll of course start off with the overview of the project and its purpose. We will explain what non-compartmental analysis is and how it tackled this process with our open source Shiny application. Then we'll go into a little bit of technicalities and discuss some challenges that we faced during the development process. And in the end, we'll discuss some plans for the future. And of course, we will open up the floor for the QA session. If you think of any questions during the presentation, feel free to drop them in the chat. We'll come back to them at the end of the presentation. So I think without any further ado, I will give the floor to Jana to discuss the project and its purpose.
Hello, I hope you guys can hear me. So for those of you that aren't familiar with the aNCA project, essentially the way that it started was with a couple of interns a few years ago having a go and having a play with some of the pain points in our NCA workflow. And we realized that there was a gap that was missing that could be a lot more the workflow could be a lot more streamlined and more efficient. And so we created this aNCA project that is an R-Shiny application that streamlines the entire NCA process and provides an end-to-end workflow from the analysis to the creation of the TLGs for the reporting. So a bit of background, our previous workflow at Roche started with the scientists creating a data order. So they would give some information on which variables they wanted, which parameters, which analytes. This would then be sent to us, the data scientists, and we would create the data set for them, including all the information they wanted. And this data set we created was not very standardized. It was kind of very specific to what the scientists wanted. This would then go back to them, and they would run the NCA on an external software. Once they'd done that, they would send the output files back to us, the data scientists. We would then create a different version that would then be sent to the statisticians, who would create the ADAM dataset. So this is the standardized dataset. And this was then sent to an external vendor who would create the TLGs, so that's tables, listings, and graphs, which were then sent for the final report. So this whole process was pretty unnecessarily complicated, involved a lot of steps, a lot of back and forth. So quite often these arrows weren't just single direction, they would be going back and forth between the data scientist and the scientist, trying to figure out, which things to change and so on. And so, it's not the most efficient process. So with our new workflow that we are developing, we create the data set as the data scientists. We don't have a data order anymore. We just create it based on what is needed. And this aNCA application, this package that we're presenting today, covers the NCA analysis, the creation of the ADAM data sets, and the creation of the TLGs, all in one handy application. And that can then be exported and sent to the final report. So this is much cleaner. It's an end-to-end process. It's a lot more streamlined and efficient. And just avoids all the problems that were there before. So the target users of this are the scientists. So the reason we made it an application is because the scientists often don't have this back-end coding knowledge. So they are the ones who are going to run the analysis on the pharmacokinetic data and use these results to make dosing decisions. So the team is the four of us who are presenting today. So people at Roche is myself, Valentin, Gerardo, and we have some others, Lucy, Kezia, Anna, and Ercan. The team at Epsilon, who are working with us as well, Mateusz, Pavel, and Ravi, and Bill Denny from Human Predictions. So this is the creator of the PKNCA package on R, which is an open source package that is very fundamental to our app as it does all the background calculations. And it's an open source collaborative project. So I'll go into a bit of background about what is NCA, as you're going to hear it a lot, but you might not know what it is. So non-compartmental analysis is a form of pharmacokinetic analysis. And pharmacokinetics is what the body does to the drug, as opposed to pharmacodynamics, which is what the drug does to the body. So we're simply looking at, is the drug going into your body, being absorbed, and then leaving again, and at what levels it's doing that. And the reason we need to do that is as it can give us really good estimates that are useful for dosing decisions. And quite often in early stages, these dosing decisions are very time critical, which is why we want the process to be as fast and efficient as possible. So NCA calculates these pharmacokinetic parameters, things such as Cmax, which is the concentration, the maximum concentration that the drug reaches in your body, the Tmax, which is the time at maximum concentration, the half-life, so how it is eliminated over time, clearance, and this really useful one called AUC, the area under the curve, which is also the drug exposure. The good thing about NCA is there's no complex assumptions required, it's quick and flexible, it's really essential for regulatory agencies, and as I said, it's the foundation for evaluating dose-exposure relationships, which are essential in these dosing decisions. So the parameters, some of them can be very easily calculated just by using observational data. So the Cmax is just the point that is the highest in your curve. The AUC can be calculated in different ways. There's linear trapezoidal method, log trapezoidal, and lin up, log down. There's also the lambda z and the half-life. So these are quite important parameters. This is the first order rate constant, and it's calculated by fitting the natural logarithm of concentration by time. Then in addition, there's lots of other parameters that can be calculated using either the AUC or the lambda z, such as the span, the AUC extrapolated to infinity, clearance, volume of distribution, etc. So we use PKNCA, which is an open source R package, and this is the main R package that we use to run the NCA calculations. So when we were creating this project, we tried a few different packages that were able to run an NCA, and this one was the best one and the best open source one, which is quite important for what we're trying to do. So I'll give you a bit of background on how the package is set up because it's relevant to how the app works. So the setup requires three inputs, PKNCA concentration data, PKNCA dosing data, and intervals. So the concentration data is very simply just a list of all the PK samples that have been taken. So all the, for example, blood samples with the concentration of drug. The dosing data is all the times that the dose has been administered and in what quantities. And the intervals are the start and end time of each dosing profile, and you also specify which parameters you want to calculate. And these are then combined together using a PKNCA data function to create this PKNCA data object. So after you've done that, you calculate the NCA. You can set your options, such as the method and the minimum values for best fit calculations. And it's a very simple function, pk.nca, which then calculates the NCA results. So there's a summary here of the steps. First, you create your concentration and dose objects, then you create your data object, and after you've done the results, you get this PKNCA results object.
Then regarding the data that is used as an input for the app, It's very simple. It involves all the three elements in one data frame that Jana has told you. So the concentration data, the dose data, and also the interval information. The important thing is that in the dataset, we have different columns. The blue ones that I have pointed out are the ones that are related with ID information. So it's the ones that identify which sample has been taken in the lab, if it involves a certain analyte or if it involves a subject that has a certain sex or race or age. Then we have concentration records that inform about the specific analyte, which value has been analyzed in the lab, at which concentration, which units, at which time has been taken correspond in relation with the dose that has been given. And then dose information on what was the dose level that was given to the subject before at the dose time, by which route of administration, at which specific unit. And with all this information, we can actually use an input for the app, and it's a very serious standard. So most people know how to code it. That's the advantage of this format. Then I wanted to give a small demo of the app. Basically, here you can see how our app is developed. You can load the file, whichever you want in aNCA format. Then you can also add filters in case you want a specific part of the data. Sometimes the scientists want to exclude certain patients for scientific reasons, of course. And then we have these logical operators to allow them to do these operations. Then in order to transform the information from the aNCA specific columns to others that are not, or to others that are for pqNCA, we allow them this column mapping section where we explain how the variables should be coded, and we also allow them for the units to specify values. They can review the data once it has been mapped to make sure that everything looks fine. And then they can go to the NCA settings where they can specify how they want to perform the analysis, in which analytes, in which dose numbers, or in which sample specimens. Also the method to use or the units that they want for the parameter results. So if they want to change a unit, it's very simple. They just select the unit format they want, and then a conversion factor will appear. So they can check that is the correct one or the one that they desire. They also can decide on which parameters they want to calculate. We have an interface that tries to simplify the process because different programs have different ways of naming these parameters. So we try to make it simple by offering many columns for this filtering. Also to allow them to choose if they want to do an imputation or not of data. For now, that section needs to be extended. Also to perform partial AUCs on which range, so we need to always give a lot of flexibility in this sense. And different flag rules just to flag the results in certain ways. We will see later how they affect the results. Something that is very important, as Jana mentioned, well, is always checking the settings for the files. But something that is very relevant is the half-life or the lambda set calculation that Jana mentioned. Basically, scientists want to look at each plot where the lambda set was calculated for each profile and see if it seems correct and appropriate. So we try to give an interface that informs them about the specificities of this calculation at the top, at the subtitle. And if they want to just exclude a point, they can do it with a double click for simplicity. They can also modify their exclusions or selections in this table that is ahead, so you can remove it, or as an alternative, you can also do it again in the plot with another double click. And as you can see, well, now it has been eliminated. Then once you are done, you can run your NCA with your specific settings. You can see whatever message or warning that the app is providing for informing, for example, about a parameter that seems to be wrongly calculated for a reason. So the user is always informed about potential problems in their data. And then these flagged results that I was talking before, they will tell you if the parameter that was being used for flagging is missing, and they will inform you with purple rows, or if it was flagged because it was not meeting your requirements, it will be in red. But in the end, these results will show you all the parameters that you want. You can always, of course, choose the specific ones that you want to study. So we give in this interface some kind of flexibility for them to explore them and to simplify the process of analyzing the data. And they can go through it entirely. You can here see that the flag results satisfy the requirements. Then the slope rules for the plots that we saw before relating the half-life, they can also check descriptive statistics. So basically they can calculate the mean, median, or any statistic at all through different groups in the data. So they can check if the race of the patient or the sex of the patient seems to have a difference influence on the drug concentration. And this is something that they want to explore always. So we offer them this possibility of checking whatever statistic they want. Then in the parameter dataset section, we produce all the outputs that they need for submission. This is something that is very official, service official or standard. So this is something that they always want to check. And then we provide additional analysis that are still under development. The important thing about the visualizations app is another section that will allow them to do a more interactive exploration, let's say, with plots where they can zoom, they can decide if representing log scale, if they want to choose different groups or analyze by cycle, and also to color or to select specific groups in the end. Here, for example, you checked how they compare the different doses and that more or less they seem equal. The mean plots show the same information, but apart from that, you can also perform the standard deviation or the confidence interval and represent it in the plot. And then the box plots for the PK parameters that have been calculated, you can also represent them in this way. We try to offer the maximum flexibility and also use plot lists so they can label the points, explore the specific areas they want, etc. And then violin plots as well. And this TLG section is the most independent one, is the one that is used for the plots that are going to be reported directly. It's not for exploration. So we make sure that they can check them and that they can make sure that it's in the proper format they want, that they can modify them in case they need to. And something really cool, for example, is that we allow them even to change the titles, subtitles with a semi-programming way or a smart texting way, where they can write the variable name or the column, and then it will be also translated through the code into the plot. So, for example, if they put exclamation study ID and then the $point study ID, you will see that this will be translated correspondingly in the title. So this allows them to at the same time interact with the data frame or the data that is inside, and also provide a particular text information. And in the same way, they can group through variables or everything. The interesting thing then about these TLGs is letting them to decide how they want to report the data. But we also have, apart from listings, graphs, and soon we will be developing tables. But as you can see, the options are very similar. We try to give as many alternatives as they want for choosing exactly what they want to report or what they want to show to the authorities. It takes a while, which is one of the problems. right now with these plots, but as you can see, they are in Plotly, and in the end, you can always check them. And with that said, I will give the word to Matthew.
Okay, so then I will take you through some technicalities and speak about some challenges that we encountered during the development process. So for starters, I would like to throw it back to the original purpose of the whole project, and it is to streamline or automate the non-compartmental analysis process. So this is a very complex process that we try to make easier, more maintainable, and easier to maintain. So we need to strike a balance between streamlining that process and making it simpler, but also allowing a lot of customization options for the user so that they can fit their analytical pipeline to their needs. So the project is split into two parts. Firstly, we have the app package, which handles the underlying logic and is based on the PKNCA package. It kind of provides more extended workflow, more customization options. And with this package, we ship the Shiny application that was showcased, which is a bit more curated, provides a graphical interface, and encapsulates a bit more streamlined workflow, but still provides a lot of customization options. The R package is basically a bunch of building blocks that we use to create the analytical pipeline within the app. And this provides the opportunity for the users to create their own pipeline if there is any to do so. This also makes the whole process easily testable and maintainable. If you have ever created a Shiny application and tried testing it, you will know that it can be tricky at times. So encapsulating the critical logic in a package makes writing unit tests and integration tests much simpler, which in the end makes the whole process more reliable and robust. For the Shiny application, I think the biggest challenge was just the amount of things that we need to play into the graphical interface. There's a lot of settings, a lot of options represented at various widgets. The data is presented in many different ways. There is large tables, there are various plots. So we wanted the interface to be both verbose for seasoned users, but also not overwhelming. And the interface has changed many times during the development and still changing based on the feedback from the users. I think the two major design choices that we have made is, firstly, we have went with a lot of tabs. There's a lot of tabs and these hideable, toggleable accordion elements. This serves a purpose to obscure parts of the interface that are not relevant to the user at the very moment, but also makes them accessible within a click or two. Furthermore, we often opted for bespoke ways of or input methods. So in the application, you will encounter not only your typical pick lists and text and numerical inputs, but also a lot of tables, toggles, checkboxes, and as was showcased, interactive plots that allow you to click around and select or deselect some data points. This is awesome from the user's perspective, but comes with multiple issues from the developer's point of view. So now we have many moving reactive parts that need to come together before we run the actual analysis. So we need to gather data from various input methods. Some of those parameters can be mutually exclusive or dependent on each other. Also, for some of the widgets, we need to pre-calculate actually some of the results so that we can kind of show the user how their setup impacts the analysis so that they can make more informed decision for the final analysis run. And so we cannot just throw it all into a box and run the analysis. We need to validate that the whole setup is actually correct, that the analysis still can be performed and it is reliable. We need to handle all the errors and warnings that can happen in the meantime. And we need to handle the edge cases, missing values, NA values, etc. So this is also a complex process that constantly evolves during the development as we expand the capabilities of the package and of the application. We are constantly adjusting, even though the blocks from the package stay pretty much the same. We constantly adjust the way we manipulate them, the way we create pipeline to make the whole process more reliable and maintainable. Then I would like to focus on the reporting part. So firstly, there is a lot of ways to present PK data. And there's also a lot of standardized plots and tables used for reporting. We want the user to be able to have them accessible from within the application. We want the user to be able to browse, view, and customize them, most importantly. But that is a lot of stuff that we need to add. So from the developer's point of view, we want to make adding TLGs easier and more streamlined. In addition, we really want to open up to contributions from people who might not have a lot of experience with web development or writing Shiny modules, but might be excellent data scientists and might not are very well. So we devised this kind of system with one master module that generates the entire user interface around the TLGs. And in order to add a new TLG to the application, you all need two things. So firstly, you will need a base R function with maybe some ggplot and plotly that actually generates what you want to display, so either a plot or a table or a listing. Then you will need a definition for the TLG in a YAML file. And if you are not familiar with the YAML format, this is basically a more readable JSON format. So a format with key value pairs, a little bit like a list object in R or a dictionary in Python. So what goes into this definition? Firstly, we have some metadata that defines things like the type, the TLG. It defines some description and links that the application then uses to generate a table or this kind of catalog that the user can browse, and they can pick the particular TLGs to add to their report. Here, we also provide the name of the function that actually generates what we want to display. So the application, the module can read that file and calls this function in order to generate either a plot or a table or whatever it needs to display. Then moving on to the options part, which is, I think, the most interesting. This is basically a way of allowing the developer to define what kind of customization options the user has. And this part of the definition handles everything that is displayed in the sidebar on the right. We have some special syntax that allows the developer to create labels, to separate different widgets. And then we have the specification for the inputs themselves. So we can see that we have things like xvar or plotVars or color variables. So throwing back to the function that I have shown earlier, those are actually arguments that are passed to this function. So the module will take the value from that specific input and then pass it as an argument to the generator function, basically making it odd file together. There's a lot of options for specifying the input types. We even have some custom inputs implemented, and we want to implement more. But basically, in principle, we can specify things like the choices that the user can pick from the pick list. You can use some special syntax to, for example, reference all the call names from your data so that the user can pick from that. You can specify the defaults and if the selection should be multiple, etc. And then one of the things that was showcased during the demo, we have also implemented a little bit of a special syntax that you can use to reference the actual values from the data. So like was mentioned, for example, you can use the $sign to reference the values from the data and the exclamation mark to reference the label attributes to have like more human readable and presentable paper options. So with this system, what you can do basically is you can add new visualization methods to the application without actually touching any of the application code. All you need is knowledge of base R and this YAML definition. So if you are interested in contributing to the project, if you have ideas for visualization that you would like to see in this kind of app, please feel free to check it out on GitHub after the presentation. And if you are interested in contributing, feel free to reach out with any questions. And yeah, so that would be it for the technicalities. I will then throw it back to Valentin for the plans for the future.
Perfect. Thank you, Mateusz. So what about the next steps now? So we first went through, many issues. So we completed many issues in the last 9 months. And the next action points will be, first the full automation of the NCA, meaning that currently we usually run one NCA at a time, so one study, but we could think about the tool handling more studies, so let's say 20 plus studies, and clicking on running, and then it runs automatically everything with of course with the default setups, but that will be the goal. We are also working on refining the UX design of the app, because we started originally the app from small to big, and then we didn't really think at the first sight to have the nice user experience, and also we don't have this knowledge. So we have currently some people in our team that are UX designers that will help us for the front end there. We also want to implement the rest of the most standard TLGs used in the pharma industry. So there are about 30 TLGs, and currently there are a few that we cover, but these are the most basic ones. We want to implement the 30 most used ones and create automation of reports, PDF and Word, and potentially other formats, and also PowerPoint, by selecting a few TLGs that are the most important for some presentations, for example. We also plan to add some options to run compartmental models analysis and non-modeling analysis. This is not aNCA. This is something more that will have to be developed, but this would be more for quick and dirty compartmental model analysis. And we will of course continue bug fixing and adding extra features. But so far we have found a lot of bugs already, and I hope we covered most of them. And yeah, as today we are also promoting aNCA and Shiny app externally today, but also in conferences in Europe, such as Fuse. And also at Rush, we are going also through the validation because all this app needs to be in a regulated environment, because we are playing here with clinical data. We need to be sure that everything is validated. So first, the Shiny app is currently validated. The NCA results are validated, meaning that they are cross-validated with other commercial software that run also NCAs, and there is a 99 to 100% match. And then we also want to run this NCA not only on clinical data and preclinical data. We want also to use maybe some toxicology data sets or oligonucleotide data. This is our plan. But of course, all this data needs to be adapted to the app. And at the end, we want also to train the scientists to know how to use the app, because it looks simple like that, but it's maybe not straightforward for them to use at the beginning. We want to improve the user experience and get them trained on the tool. But we are trying to make the tool as friendly as possible. So just before concluding, I want to make a bit of summary of the app. So the app started initially at Roche. We started first not in a Shiny app. We started in R coding with trying to do an NCA in R. This was the purpose. Then we tried many packages, because there are many packages available. We started with one, we changed, etc., etc. We started with this development of this R beautiful Shiny app on the right, and then we continued, and we changed the package. We face many issues about R Shiny, because we are not necessarily R Shiny experts. We solved many bugs, and after a while, we also included the preclinical team in this project, because we found out that this is not a clinical issue. NCA is also running in preclinical space, so we could join forces there. So this is what we achieved, and around July last year, so 9 months ago, we opened up the aNCA Shiny app on the Pharmaverse, and this was huge value for us, because we managed to get Epsilon as one of the best stakeholders for in terms of software development. So they brought a huge level of expertise there, and this helped us to develop completely the backend of the app and reshape it, because it was not very clean. We are not software developers, we are data scientists, specifically pharmacokinetics data scientists. So for us, it was not straightforward software development, even if we studied it at school, for example. So we got a very high value there from Epsilon. Then we reshaped the app, we did many things, and then we again did a beta testing with the scientists, solved again hundreds of bugs because we were developing more and more and adding more and more features. At some point, the Shiny app is looking good, which is right now, but now we are focusing on the user experience, the UX design of the app. So overall, at Roche and also in other pharma companies, the interest of this app skyrocketed across departments, and now everyone wants to use this app in preclinical space, in clinical space, using different dataset input. So it looks like this app will be used in the future, and we'll continue to advertise it. So now to conclude, so this aNCA Shiny app is an open source Shiny app collaboration, and it allowed us to unlock new skills because, as I said, we're not software developers, and then learn from each other because we worked in a Scrum environment, so we collaborated a lot together and put some rules so that we can progress together and code together the right way. So of course, this collaboration accelerated the progress on the development of the app. This was clear, and this is why this is why collaboration and Pharmaverse open source is great. And I will say from a product owner perspective, I'm coding sometimes on the R Shiny app, but I'm not the one coding the most. And when I see the Shiny app every day, I feel like from the front end, well, it looks similar to what it used to be, and even after a few months, because I don't see everything in the background of the app, so the back end. So the back end can be completely transformed and reshaped so that everything works much better. But I don't realize it because the front end doesn't change much. So this is also something to keep in mind: is that sometimes you feel like the Shiny app looks simple, but I can tell you in the background it is pretty advanced there. So if you want to join or are interested in the project, you can scan this QR code. We have more and more contributors now to the project, and we hope that other pharma companies or software development companies will join. Why not? To help us. But if you're interested in this, don't hesitate to ask us questions or check our GitHub, check the code, and I think it's full of knowledge there, so don't hesitate.
Okay, thank you so much to all of our speakers. I am then opening the Q&A session. I can see already some questions in the chat. So firstly, a question or questions from Pawan, mostly about the data format. So what data format is required for users to upload their PK data into the application? Does the application support CDISC, SDTM, or ADAM formatted datasets? Also questions about validation to ensure that the data is correct. And a question whether we can upload multiple analytes and studies at once.
I will take the first one. Maybe you can take the second one, Jana and Gerardo. So about the data format, currently the only data format that is allowed is a dataset, ADAM dataset. So it's an analysis dataset, SEDISC standard, that is called aDNCA. So it's similar as ADPC. It's a new standard. aDNCA is a new standard that was given by SEDISC 1 or 2 years ago maximum. So you will have to shape your dataset this way. So you will have to use different SDTM with doses, with peak pharmacokinetics data, and then gather them into aDNCA. We are also working on in parallel on the data creation, but this is not open source. It might be open source at some point. And regarding the validation, so yeah, if you come up with a dataset that is not ADAM, that is not aDNCA, you might have some struggle to know which variable to map. So if your dataset is incorrect, let's say you have NA values in your dataset, in the specimen variable or in the analyte variable or whatever, this will give you a warning. Okay, here you have an issue, or here you have a duplicate, and we cannot analyze duplicate PK samples. So that is already ensured. That is already ensured in the Shiny app. We have errors, warnings, everything for you to potentially understand, hopefully understand what is the issue in your dataset. And I will let you the last question for the multiple analyte studies. Gerardo?
So like Valentin said, there is validation in a way that if you upload data that's not formatted correctly, it will let you know, and it will let you know why. So currently we can do multiple analytes. We can also do multiple studies. The only thing is you can't select which study. If you upload a data set with multiple studies, it will run on all of them. But you can select which analyte you want to run. But everything is grouped by study ID, subject ID, analyte, so parameter, and matrix as well. So everything is covered, I think, hopefully. Thank you for your question.
Okay, so we have another question from Jeffrey. Have you considered integrating PKNCA functionality with the TIL framework? And I think I can take this one because we did consider using TIL, but it was definitely last year when the project was ramping up. Then we have decided that the capabilities of TIL framework well, not quite fit for our vision. I mean, in order to incorporate TIL, we would still have to write a lot of additional functionalities ourselves. So decided to go a little bit of our own way in developing the package and deciding on the architecture of the application. However, I've seen that TIL has developed a lot from that time. Currently, there is no direct talks about migrating the application to TIL, but we are open to different possibilities. And since the application evolves constantly, as I was saying, both the interface and the lodging the user experience, I wouldn't rule the possibility of migrating the application to TIL or implementing parts of TIL into the application. I wouldn't rule that possibility out. We'll see. We will need to inquire about exactly our needs and vision and how TIL kind of fits into that vision. So, do we have any more questions? I will give it a moment if anyone. Okay, we do have a question. Ray asks, in terms of managing reactivity, are you employing caching? For reporting, are you looking to integrate Markdown LaTeX into the app? So we are not employing caching currently with the reactivity. In any way, could be a useful idea for kind of optimizing the application. Currently, we do not encounter any critical issues with the reactivity or the performance of the application, maybe apart from the TLGs, as you have seen on the demo, the generating of the plots can take a little bit of time. So that might be an area to explore. Currently, we are not doing it. And in terms of the Markdown and LaTeX, I know there were some ideas previously. I don't know if anyone has a comment on that.
Yeah, I will comment on that. So I will first comment on the reactivity, the caching. So we have deployed the Shiny app on an RS Connect. So I think it's called now POSIT Connect server. Actually, the app is very big. We realized that, and some of our scientists experience some bugs, disconnection from the server, or like long disconnection when we click on a button and it's too long, things like that. I think it's also due maybe to the not very good Wi-Fi. So this was an issue from the RS Connect, but this is not something that we can do, I think, but we have maybe to discuss it internally because I think it's a restriction from RS Connect. From the TLGs, it's quite long now, but we are working on it to make it not ggplotly, and therefore everything will be faster. And regarding R Markdown, we thought about it. I mean, by by default, usually the FDA, so the health authorities of the US or Europe, is asking for, I mean, they are not asking, but essentially most of the pharma companies provide PDF or Word usually, and R Markdown provides, well, PDF, Words, and potentially HTML. But where I see the potential of R Markdown is for HTML and interactive plots, such as with ggplotly, for example. So we could think about it. I don't know how we'll do. Yeah, I think it's possible to do it in R Markdown. But what we want to do for sure is all the code that is running in the background will be kept, and it will provide the R script to rerun everything that is running in the back end of the Shiny app. So if you want to rerun the NCA via command line in R in the console, you could get this code. If you want to run the TLGs, one single TLGs, you could get the code of this TLG. So that's something we want to do. And LaTeX, I have not. I don't think it's applicable for. I mean, we didn't think about it, and I don't see much value, but maybe we can discuss it. Yeah.
Okay, do we have any more questions? I will give it another minute. If anyone has any questions, please feel free to drop them in chat. So yeah, if we don't have any more questions, I think we'll be closing the ceremony. So again, thank you so much to our speakers for introducing the project. Thank you so much for taking a time out of your Tuesday to come and listen to our talk. Thanks again to everyone involved, and I guess have a nice day.
Thank you. Have a nice one.
you.
Thank you.